Trudeau, CEO of OpenVault. Really thrilled today to be speaking with Dr. Rouzbeh Yassini, who is widely regarded as the father of the cable modem and an author of a new book called The Accidental Network: How a Small Company Sparked a Global Broadband Transformation. So, Rouzbeh, thank you for joining me. And why don't we just get right into it? And maybe just tell us a little bit about the book and why you decided that now's the time to share your story.
Thanks, Mark. The book is titled Accidental Network, and at a high level, it tells the story of the cable industry's transformation from a television-only media to a breakthrough infrastructure for connecting millions of the citizens to a high-speed data network. It is told largely through my own personal perspective as the originator of the very first residential cable modem and how my small company, Land City, was able to bring it to the life. And the main reason we're telling the story now, in my books, we started this vision about 1987, and it's a story that needed to be told. And in the last 37 plus years, no one has indicated how our country and the globe access the broadband. So it all started with a vision of mine in 87, and Stuart and I thought might make sense. So we started this activity back in October 2022. So 35 months later, we were able to get the book out that talks about how the cable modem was invented and why we provide the technology free of royalty to the DOCSIS standard that built the foundations of the high-speed networking for the cable industry.
Excellent. Well, certainly those of us that make a living in the industry and particularly the cable broadband industry owe you a great debt of gratitude for this innovation. So certainly appreciate you and your team's innovations there. Was there a kind of an aha moment that led you to the cable modem?
No, my background, Marcus, started with General Electric. We built in GE TVs, VCR cameras, all the entertainment stuff using coax. Then I joined a company, Proteon, in Massachusetts, where they're doing high-speed data networking. And it just was intuitive to me that, wait a minute, why do I need two separate physical cables to do data on one and a voice and a video on the other one? And that aha moment, I went to our CTO at the time, which was the founder of the company Proteon, and said, hey, we can put the voice data video all over the coax and get that going. His view was, well, stick with the data networking because that's what our company does. If this was going to be done, somebody would have done it. So I quit my job next day and started the vision that these two things can come together and work over one cable. And the only thing out there that was lowest cost and a common denominator was residential cable TV. But I had three problems. Number one, the cable industry didn't want to have high-speed data. They said, why would anybody want to connect a computer? Because there was no computer at home. Number two, it was very expensive as far as the technology and creation of the technology goes. And number three, it was no market because the World Wide Web was not even invented yet on that. So with those three barriers, those were aha moments. But I knew that coax and a residential cable TV has the bandwidth to handle that. And that's what led up to the whole vision of execution.
Well, as a fellow entrepreneur, I understand the challenges of starting a business and the trials and tribulations that you go through. So you touched on a few of them, but what are some of the maybe the other biggest challenges you faced and that you had to solve for as you went through this process?
So cost of the product was one, and the time to the market was the other one. Let me expand on the cost. Original prototype of the technology I made was about $18,000. The box was about 80 pounds, using about 300 watts of the power. That's not the type of device you want to put in the people's home. It just does not work practically. The second one was, from marketing point of view, to convince the cable industry there is a business for this actually, and help them to make the cable plan two-way, because the cable plan at that era was still one-way system. So let's talk about the cost. I had two choices: either get the existing cable modem prototype we built and try to shrink it, or re-architecture and redesign it in a manner which will be scalable for decades to come. So we took the long path. We said, let's go re-architecture instead of just shrinking it. By re-architecturing it, we decided to stick with two principles. One was Ethernet data principle and SNMP and IP on one side, and the other one was a standard 6 megahertz. So we kept those two the same, and we had to generate a new integrated circuit. At that time, the ICs were developed old-fashioned way. We did through the simulation, which everybody says we're gonna fail, but our silicon was so big that we had to do through simulation. So that was a long process and long journey to the success. And the other one was get our cable industry to make their cable plant two-way and help them and teach them how it works, which actually line up with your services and the project that you guys are doing in the industry right now. So making the cable plant two-way and making it integrated design of the silicon that we needed, those combination really helped us to get to where we are to pass our technology calmly and nicely to DOCSIS. And DOCSIS was able to scale it up and still provide the evolution of where a number of this generation yet to come on the same principles.
Yeah, so that's interesting, taking the long-term approach that you took. Did you ever, though, back then envision what it would become and kind of the power of what's now DOCSIS 3.1 and 4.0? And did you ever envision that?
It's a great question, Mark, because we knew as we build our technology, I wanted to keep the first product simple and functional. And we were used to refer to it as the puppies. We will go to cable operator, leave them a puppy, and 4 weeks later try to get a puppy. Nobody wanted to give it back. That's why we got 90% of the market shares in the period of time from 87 to 1996. But we pulled a lot of hooks and the connectivity and upgradability in our technology. For example, the quality of the service, QoS. We could not have turned it on in the first generation because we didn't even know what consumers look like, what the traffic would look like. But we had a CTO that asked us, hey, is it possible for me to throttle the speed and downstream and upstreams to this level? So we put those hooks in. We also put many hooks on the network management and many hooks on the quality of the service to be all be built in. As generation of the technology came across, those hooks got activated. So did I imagine in a sense of the evolution that we are seeing? Not exactly, but we knew from data networking what type of valves and connections and the hooks we need in our technology. And because we adopted the data standards of the Ethernet and IP on one side and 6 megahertz on the other side, we took as many of those hooks, we brought them in together and built it in the technology and let the time and the consumers and the demand would request those things to be turned on. So so it was not really truly what I call blueprints, but it was engineering, genius engineering to build it in and wait for the timing.
Well, that foresight certainly helped us as a business because we rely on a lot of those hooks that you built in on the early stages. So that today we still leverage that thinking. So that's fantastic. So what would you say would be the key kind of staying power for DOCSIS? Because we as a business, we started OpenVault 15 years ago, and even starting back then, the demise of DOCSIS was coming, right? And you still hear it today, but yet it's still running strong, right? So what do you attribute to the staying power of DOCSIS?
I think 3 things has happened to the DOCSIS. I was personally responsible to make sure as I transfer our technology to a standardization through DOCSIS, which Cable Lab led that activity, we wanted to make sure that there would never be a hardware recalls. So we provide not just the golden system through interoperability. We made sure multiple silicons are there, making sure the multiple CMTSs can work together with the modem. So we really did a great scalability of what I call interoperability. So with that, we really created a reliable foundation and base technology. That's on one side. The second side is the government of the US. Actually, as we were building our technology back in 1989, 1990, we went to the number of the government site. Some of them has as many as 5,000 users. And before even the cable industry and the cable operators and residential cable plant have 10 or 20 customers, I had 5,000 government users on the campus on my network. So we saw everything we need to know. You would laugh at this, Mark, because the place is Rock Island Arsenal, which is right in the middle of the Mississippi rivers. And guess what? They happen to have a major flood in the rivers, and all manholes got full of the waters, and the network has stopped functioning. A four-star general called me and says, "Hey, you get your butt in here, and we got to get this thing fixed." And you are blind in 1989, 1990. How do I troubleshoot a network? That was our first flag. We need network management. We need network tools. We need network diagnostic. We need to be able to define and identify point by point of this cable, what's going on. And that's led to our IP-based SNMP network management for the first time over there. And I won't bore you with the details of how we got that, but when we got back to our facility in Andover, Massachusetts, the first thing we did was spend 2 good years to really make sure our MAC layer protocols and our QPSK modem had all the hooks that it takes for every piece of functionality that it requires. And then my colleagues, 5 years later, said, "Hey, your network dies at 5 p.m. every day. Why is that?" Well, we also used the same tool to figure out that what was happening in Long Island at 5 o'clock when the trucks are going through the roads in there, and they're using the 5 to 10 watts CBs. Some of the coax have been stretched, so there is ingress is going in every time they use their radio from the trucks in the natures. And the same thing happened with our Adelphia friends when the Hunter were coming in town, and all those network management tools became to be available. Fast forward to 2013, Bill Hildebrand, my friends in the cable divisions, wanted to use our high-speed data that says, "Hey, we need to have eyes and ears on the network. We need to predict what's happened." So because of the variety of the MIPS that we had, we were able to show them through what we call at the time a super knock that, hey, if you look at the packet drop, you look at the packet loss, you look at the level of the performance of every modem, every home, you can actually map where your service is going to degrade or not over the time. And that improved their customer service tremendously, especially when hurricanes was coming in their town. They were able to use these tools to really figure out. So one of the reasons the DOCSIS is lasting long because it got the tools, it got the capability, it got the reliability, it has the cost, and it just simply works flawlessly, and why not?
Yeah, well, you're certainly speaking my language with your proactive network maintenance discussion there, because obviously that's a focus of OpenVault, and our view is these networks are not getting simpler, right? They're getting more and more sophisticated, and a lot of times, in almost every case, we see hybrid networks as well, DOCSIS fiber. We see lots of different infrastructure manufacturers contributing to the network. So it makes our job a little difficult to keep up with all that sophistication, but operators really need these management and maintenance services.
And right? I take my hat off to you, Mark, because you guys have basically, at the time when we did all this stuff, nobody knew what the word AI, artificial intelligence, is, but we call it network management, network monitoring, network diagnostic, and network tools. And this really DOCSIS is a very smart based network and has a lot of capabilities to be able to do that. And that gives a very nice vision also from customer point of view, where you can tailor speed to a certain customer to the others. You can detect the problem before they even happens. And more importantly, you'll be able to measure the health of the network and reduce your cost of operation significantly. Because it used to be you send a truck, it used to be you wait until 20 customer, 30 customer to call. And that's just not scalable for a million plus, a billion plus network around the globe.
Yeah, and what we find too is, a lot of that's the default answer, right? When there's a call into customer care, as we roll a truck, right? And when you have these kind of more automated tools, you can avoid that expense and actually make the customer, happier. So, between kind of the proactive network maintenance and our profile management application tools. Based on what I'm hearing, you seem to believe these are very important for
absolutely.
For
I tell you, now everything is streaming, but when we had analog video still at the same time and digital video going on, our number of operators were using the high-speed DOCSIS to actually predict the health of their own video as well, because they could actually see with the number of the packet drops, the number of the occlusions, and number of the elements through this type of technology that you and others have, be able to predict which neighborhood in their system is actually going to have problem with video, which power supply was acting up, which amplifier was acting up, and that provides them anywhere from 24 to 72 hours advance notice to predict. So by the time a customer calls, they will say, don't worry, we are already there. And they increase their reliability and the customer service uptime by about 20 to 25% just because of the tools you guys are providing.
Yeah, and we're thrilled when they're actually adopted in a proactive way, right? A lot of operators still to this day, even though it's called proactive network maintenance, they use it in a very reactive way, right? And so helping them understand, how they can be more proactive and avoid the phone calls ever coming in, right? Is the goal. So I guess I would also
and
ask
I think
you,
one thing else there, Mark, is that number of the operator has now understands that their operational expense and capex actually could also be managed a lot better with this type of predictability. So I think as time goes on and these tools get more adopted from every part of a user point of view and every part of the operator's point of view, it will really open up a whole new doorway for them. And you really cannot operate these systems anymore without this type of visibility. I call it the X-ray to the network, and what better than that,
Yeah, well, we certainly agree with that. So, how would you feel, the value of DOCSIS 3.1 and 4.0 eventually, and perhaps future iterations, helps the industry really compete with fiber? Because, there's a lot of talk about fiber networks being better, and that's the future. But, what we see is an industry that has, if they have the tools, they can very effectively compete with fiber. Do you have a view on that?
Yes, indeed. So let me go backward. When we started back in 1987, 88, wanted to do high-speed data over residential cable, everyone said, no, you got to go FDI, you got to pull in this fiber. I would say, well, how are you going to afford it? The cost is unbelievable. And cost still is an issue. The reason we created cable modems and as a result, a standardization of DOCSIS, that the coax had a significant value, lower cost for the thing. So originally back in 1990 and 2000 and 2010 and even 2020, the fiber has to start penetrating in where it used to be 45 and 50, 60 amplifiers. Now we are down to 1 or 2 amplifiers. And the last mile is still coax. And that still saves time because of the architecture of the CMTS and the cable modem and everything else we have. As long as that physical coax is there, the DOCSIS will survive, and DOCSIS has a life, and the DOCSIS/fiber behind it are the lowest possible cost of the high-speed delivery. It goes all the way up to the 14 megabits theoretically, and the existing 4.0 type of a technology to deliver. So nobody will replace that DOCSIS. The time that DOCSIS will be replaced is where the last mile has come to the last 100 feet, come to the last foot. At that point, you have multiple technology that can bring that in, so the fiber direct to the home would be practical. My own estimate is that perhaps for cable industry, until year 2040, we still have a good life to the DOCSIS to go on, another 15 plus years on that side. And even then, it's still questionable that some of the network in some part of the country or part of the world might still use the remainder of their coax. There's no reason. Because think about it, at 14 gigabits to home, we used to have data speed to National Science Foundation. I mean, there's really no application or services above and beyond that you would actually need at this point. Also, we will figure it out that because of the scalability of the DOCSIS and because now we have turned the whole thing to the digital platforms, and there's where your voice and the video also goes across that. So you really have centralized and integrated network management for all the services, all the capabilities. Think about this way. Netflix was nowhere to be found, and now they have 230 million customers. And all that 230 million customers are going through the pipeline that we have provide. So visibility is very important. I was watching my football this Saturdays and this Sunday, and was a significant technical difficulties on their side of them transmitting that videos. And when I called them and say, hey, what's the story? They said, don't worry, we already and have noticed your area having this type of problem. So that was telling me they were using the tools, and I was very happy to hear that.
Absolutely. Who's your team, by the way?
Oh, in this case, it's New England, because I live in the Boston area. So,
Okay.
but I've been the supporter of Pittsburgh when I went to schools there, and then Denver Broncos when I was there 6 years to helping the cable industry create a DOCSIS standardization. So I got 3 teams.
Well, you're spreading the risk a little bit that way. So, it's funny you mentioned Netflix. We as a business, all of a sudden our solutions became a lot more interesting to operators once Netflix took off, right? And I remember back in the day, Netflix was kind of a 4-letter word for a lot of operators,
Sure.
just having to deal with the capacity needs when they weren't necessarily ready to have to deal with it. But, now it certainly seems like with DOCSIS 3.1 and 4.0 coming that, operators have future-proofed their network for a little bit. None of us really know what that next killer app is going to be, or that's going to chew up bandwidth. But when COVID occurred, we were bombarded with questions from the media and such. Are these networks holding up? Are they able to support the capacity demands? And they really were. They did a fantastic job. So do you see, we've talked about 3.1, 4.0. How many more versions of DOCSIS do you think are left?
Let me just go back to your earlier about the COVID experience. Our network is scaled up and worked with the COVID because for same reason, same fundamental that in Rock Island Arsenal, we got it up and running and working through the flood that we had at the time. The network was designed robust with the tools and the resilience to really handle that type of a thing, not just the traffic, not also the harsh environment. Just remember the return channel on the cable was really a nasty, nasty environment. Some people used to call back in 1987, 88, when I went to the venture capitalists to get some funding, which nobody gave us. They used to call the cable system as a sewer system. Everything goes there, the bad things comes out of it because of the noise, because of the trash, because of this, because of how can you put data across that, right? So the scalability of the network during the COVID, it was one of the fundamental of what the engineering wise put in the cable modem, put in the DOCSIS, and evolutionary. Every time we have gone from DOCSIS 1.0 to 1.1 with the cost to the 3.0 to the 3.1 and 4, this transition has been smooth and without interruption and without. Why? The reason is because engineering toolbox that we have created is evolutionary and keeps going on. So as I said on the DOCSIS, you can call it whatever DOCSIS number you want. The DOCSIS will continue as long as there is a bit of a coax left in the infrastructure. And today, we're going up with the OFDM and the SC-QAM, and we can put, as I said, theoretically 14 gigabits on the downstream and 5 gigabits on upstreams. I don't know exactly what the cost of those modems is going to be yet, but it's coming pretty quickly. And I think, as you said, we can't guess what killer application is, but what we can guess is that the full digital spectrums to be utilized through the DOCSIS can be. And at 14 gigabits, I don't think we're going to have any problem to handle average users going on. But DOCSIS will be replaced the time that coax is gone away from the infrastructures. And my guess is that will be around year 2040. For me, it's a very monumental time because I'm the one who started putting the data over the cable, and I will be the one who probably will see if my life allows the data going out of the DOCSIS. And that's not a bad thing. That's necessarily good thing. But one of the challenges on the DOCSIS we've done was the multi-vendors interoperability, making sure that maintained. Some of the concerns I have with the later DOCSIS version that we might have lost that capabilities of having multiple vendors. If we lose the multiple vendors capability, the cost is going to go up, and that's going to damage our service delivery. So I hope the people in charge of the 4.0 and 4.1 maintain that interoperability and maintain multiple silicon and maintain multiple vendors. And if that continued, that will help the DOCSIS life cycles.
Yeah, and I think, for us, that certainly complicates matters, right? Having these multiple vendors, they don't always support the protocols exactly the same way, and so we find ourselves having to work with lots of different scenarios, right, in order to make our solutions work. So, like we said earlier, it's just getting more and more complex, right? So,
Yeah, yeah.
you kind of answered this a little bit, but let's say DOCSIS does go away in 2040 or even before. You touched on it, but how would you really feel about that?
So, every technology has a time for itself. And DOCSIS and Cable Modem did an excellent job to transform the cable industry from video entertainment to the full digital services and the streaming. So it's really fine with me to see that moment, because the 2 billion connected people over the world is a great satisfaction. And I really hope that interoperability be maintained, that you don't have to deal with multiple vendors, multiple case studies, and so on and so forth, because we built DOCSIS 1.0 thanks to the certification board in the cable industry, and through the Cable Lab. We maintain integrity of the multiple vendors, multiple sources, and all interoperate together and all follow the same basic specification. If that keep going, I think would be very nice for the DOCSIS and the consumer and guys like you, because in the end of the day, if the reliability of our data get compromised, we're all going to pay the price, and that side. So hopefully we maintain that, and hopefully you guys with the bionic eyes and AI tools that you guys have put in the system will really help the cable operators to extend the profitability and life. Because I told you, we saw it firsthand with the Cablevision that this type of network management tool, this type of visibility impact the OPEX and CAPEX for them directly to the bones,
Yeah, I could not agree more. So, well, that's really all, Rouzbeh, I had for you today. I really, really appreciate your time. Thank you again for your contributions to the industry. And again, those of us that make a living basically on the backs of what you built all those years ago. So thank you so much.
It's a pleasure. And thank you so much for you guys leading such a company. Because a company like yours 20 plus years ago was not even could imagine. Nobody wanted to really pay for this type of services. But you guys done a great job, and look forward to see you in the industry association somehow. Take care, Mark.
Thank you, Rouzbeh. Take care.